And our next speaker is Phil Bedard from Cisco, and his topic is optimal route reflection technology and deployment. Thank you.
Thank you. I don't think there's anything more exciting than hashing and to cause lots of discussion. It's a huge topic these days. I think every network's run into it. Hopefully this is just as exciting, but maybe not. So my talk today is on optimal route reflection, which is sort of an enhancement to something that has existed for a long time. And I just kind of want to do a quick kind of survey of the room. Who's actually heard of optimal route reflection? That's a pretty good number. Oh, there you go. The other question is, who's actually tested optimal route reflection in sort of a lab or simulation environment? So I see like 5 people maybe. And the next question is, who's actually deployed optimal route reflection into a production network? I see one guy given this, which is not surprising. I was actually looking for somebody who's deployed it that hasn't tested it in a lab, so I could write down your name and give that to my friends. But anyways, so just to start off, just a quick BGP route reflection refresher. I think most of the people in this room are very familiar with this. It's a widely deployed iBGP network scaling mechanism, codified in RFC 4456. I'm not going to go through this whole list. The kind of an important part about this is the best path selection process for just BGP in general. It's specifically what's used in iBGP networks. And this really comes when you've got the same prefix coming from multiple peers, and you have to kind of make a decision, there's going to be a tiebreaker decision process that's followed every time. And this is sort of a best path selection process, and it's sort of a simplified view of it. And maybe 15 years ago, this was the process. I think if you look at a modern kind of best path selection, it's probably 15 steps by now with some vendors, as we've added more kind of BGP capabilities and more attributes to make decisions on. The important one that kind of we're looking for here, though, is the lowest IGP metric to reach the resolved next hop address for that prefix. That's kind of what's important and sort of rooted the problem that optimal route reflection hopes to solve. It's a very typical kind of tiebreaker within a service provider network. And, typically we kind of refer to using that as your attribute of a tiebreaker as hot potato routing. And the reason you use that is because you really want the traffic to exit your network at the lowest cost and shortest path possible, because generally that's the lowest monetary cost. So you want to get that traffic off the network as quick as possible. So you're using that lowest IGP metric cost. So I guess what's wrong with that? We've been doing that for many, many years. The problem comes about when your route reflector does not exist in close proximity to the client that it's serving. But this is kind of a network example that most people probably wouldn't deploy. It's really just a quick network example to state what the problem is. And it's a very simple network where I'm connected to the same peer in 2 different regions. That peer is advertising the same 1/24 prefix to both locations. My peering routers, they're sending that to a pair of route reflectors in region 1. The client that they're serving, though, is in region 2. Well, I said typically people don't deploy networks this way. But the problem happens is that that route reflector, he's doing his best path selection process based on his proximity in the IGP and not his client. So he picks the best path for him, and he thinks that's also the best path for his client. And obviously, in this example, that's not the best path. So now my R1 router, the client, is actually using a path all the way across the network. It's suboptimal. So that's sort of where the optimal route reflection comes from, is solving this proximity suboptimality issue. And that hasn't, it's been a problem, since the inception of route reflection. It's not something that's brand new. It's kind of led to, the deployment option that you see today is typically people deploy, a hierarchy of route reflectors. And the route reflectors are typically always placed near the clients. In a kind of a typical service provider network where I have a backbone and aggregation and access, those aggregation sort of AVR routers, over time have typically been the route reflectors with the access network clients connected to those. So that's a widely deployed, solution. I kind of, give a hint here as to what sort of the issue with that is, and it limits where you deploy the route reflector. Obviously, that, proximity, suboptimality thing it's going to play a part if I want flexibility in where I deploy that route reflector. And over time, we've had other ways to sort of solve the issue. I kind of give a couple here: diverse path and shadow route reflectors, and add path. You can really group those into the same, type of solution, which is I'm just going to advertise more paths to my client, and I'll let my client figure out the best path. So the route reflector is not really doing anything, special in those cases. It's just, if that client has more paths to choose from, it can make that path. So in my kind of simple network example, I could simply run add path with 2 paths, and it solves that network issue. The issue with that is kind of as I expand the network to, more peering centers and more locations where I'm getting, the same routes from the same peers, I just have to keep on advertising more paths to that client. And that can be an issue because, BGP today, especially if, say I'm getting, 6 transit feeds from all over my network, it's pretty chatty these days. I think there was a presentation from like Tim Evans yesterday on, OpenBMP at Panda, and he showed kind of the amount of churn in the network, or the churn in the global BGP table today, and it's pretty immense. Like even the network that I had worked on previous to Cisco, you're talking about, potentially tens of thousands of BGP updates every day. Do you really want to be sending that to all of your clients? Not really. So route reflector, they have a property of they kind of dampen the noise as well, if they're deployed correctly. Another kind of popular thing that's popped up in the last couple of years is sort of internet and the VRF type solutions. There's other reasons why people deploy that for security and policy reasons as well. But it has the property of, if I use a different, route distinguisher per kind of peering router, I now get a unique route, and I don't have sort of that best path selection process to go through anymore on the route reflector. It's kind of the same thing where I'm just advertising all the routes to the client, and it gets to figure those things out. There is a kind of a solution for the network proximity using tunnels. You can use GRE or IP tunnels, and you're basically making that route reflector, no matter where it is, appear like it's connected near the client. I'm not a huge fan of that solution. I'm not a huge fan of using GRE tunnels to try to connect all those things together. And sort of like there's some additional kind of motivating factors these days that have come out more recently in trying to solve this problem of placing a route reflector anywhere in the network. Centralized route reflection has kind of become more popular as people are looking to move sort of network functions away from deeper in the network, and especially kind of compute heavy things like route reflection, or things that are purely control plane functions out of the network and sort of into a data center where it's much more scalable, where there's more compute power. Another thing that's kind of come to be popular recently is sort of virtual route reflectors. So pretty much all of the commercial vendors have virtual route reflection software today that's highly scalable. It runs very well. It's stable. There's been actually a few good presentations at NANOG covering these topics over the last few years. Rafal, who's actually giving the presentation after me, gave one a few years ago on centralized route reflection and the benefits of that. Obviously, then ORR was fairly new, so it wasn't a great solution then. And then VRR, there's a fellow, Mark Tinka, that has recently gave a very good presentation on his deployment of virtual route reflectors in his network, and how that's, his presentation is full of great things on why virtual route reflection is a good solution today. He also did not have the benefit of ORR in his network, so his solution actually places those VRRs very close to the clients to get around that proximity issue. So that's some background to everything. So like, what is optimal route reflection? Where did it come from and originate? So it was actually introduced in a draft in 2011, and it is still not an RFC. And for those somewhat familiar with the IETF, that's probably not too surprising. What's a little surprising about the kind of the ORR draft is that it's gone through a number of changes over the last 6 years. If you look at the original version of the draft, it's very different than the draft that exists today. That draft actually proposed, BGP protocol changes. It's a standards track. It's still a standards track document, but The existing version, or I think they're on -13 now, does not propose any changes. And that kind of happened organically over time, the people working on it. They did not want the optimal route reflection function to require changes on the clients. So it's something that's completely encased in the route reflector. It's purely a route reflector function. It doesn't require any kind of extensions on the client or new software or anything like that. The current draft actually specifies two types of optimal route, optimized route reflection. The first one is the one that we're going to talk the most about. And to put it very simply, it's doing the BGP best path selection process based on the client IGP perspective and not the route reflector's IGP perspective. There's a second version, or there's a second option in that draft, which is selecting the optimal path based on a policy. And it's very vague in the draft, and I think it's left that way, on purpose. It's really kind of a placeholder for a user-defined policy to determine, how paths are being advertised. And a very simple example is I may have a policy that says this client always has to send traffic to this exit point in the network. No matter what the topology looks like, I always want to send traffic to that exit point. And that's kind of an example of a policy-driven optimal route reflection. But like I said, today, we're talking about option one, which is the sort of optimized SPF method. Just like any route reflection, there's no requirement that the client actually use the path that it's reflecting. In the first example I gave, if that client had a connection to locally to the peering router, it would just have used that path instead. So there's no requirement that it use that path, although it's something people are kind of looking into as ways to sort of force the client to use that path, but that gets very much more into sort of the BGP programmability and network programmability. Today, it's just purely a route reflection function. So how does BGP ORR work? And I think most people are in your heads thinking this is fairly simple, and it's really not that complicated. The disclaimer is this is sort of what I know about the Cisco implementation of ORR, but I can't imagine other vendors are particularly different. So the first step is that route reflector has to have the IGP topology so it can run its own computations with the client as the root or a seed node as a root. So it has to have the entire network topology on that route reflector. So that's really the first process is topology acquisition. In the Cisco use case, there's a specialized process that's called ORR SPF, and you can see this on the box. You can do a debug ORR SPF. And what it does is it extracts the node IDs from that topology. And I'll say sort of, one limitation with sort of the Cisco implementation of ORR today is your BGP next hops have to match those nodes. So if you're doing something like running, multiple loopbacks for things in the global table, that kind of may break things. So it expects sort of this one-to-one correlation between, ISIS nodes and BGP next hops, which is fairly common. Your peering routers may be setting, next hop self or something like that. I think that's fairly common in service provider networks. And so it works most of the time, but just there are some caveats. So what it does once it has that topology table is, it runs SPF to each one of those nodes with the client as the root of that SPF calculation. Once it does that, for each kind of optimal route reflection group that you've created, it creates a separate rib for that. And it builds this next hop table that it can later reference during the BGP next hop selection process. In the case of Cisco, when it reaches that step, if it reaches that step, when it's comparing different routes, it kind of forks off to the ORR code, and it really just returns the best path, the same that the normal BGP process would. And it's that way on purpose, just so that none of the other BGP code is really touched. The operation kind of works the same as normal, only the route reflector is not consulting its local rib for those costs. It's referencing this ORR specific group rib for those costs. Like I said, and making it sort of agnostic to the rest of the BGP code means that it's fully compatible with anything else you're doing in BGP, including add path. So like I said, it's sort of something that they designed from the beginning to be very flexible to the rest of the process. This is sort of the same network example, and as you can guess, now I've deployed this centralized ORR, and I don't really have it in any region or anywhere in particular because it can really exist anywhere. In this case, I'm actually using BGP-LS to do topology acquisition, and I'm a big fan of using BGP-LS to do that because it truly makes the route reflector out of band from your network. If you're using something like an IGP adjacency, there's still sort of a small chance that that VRR could become a transit forwarding node on your network. And if you've ever used that software, you really don't want that to be a forwarding transit node on your network. You'll end up dropping a lot of traffic. So in this case, R1, it gets that optimized path from the ORR because it's doing those SPF calculations, and creating that new RIB that it's using when it does the best path selection process and advertisements for that client. And just to familiarize myself with ORR and how things work, it was fairly simple to write a couple of applications that used ExaBGP. So I basically have an application that really just ingests all of the data, the topology data, the peering routes, and all of that data. And then there's another application that is used to do the announcements to the clients. So I simply just query, via a REST interface on my sort of main topology and network information acquisition application with the client IP. And what that returns is sort of the optimized routing table to advertise to the client. And like I said, really there's nothing too fancy about this. That main application, when it gets a request, it builds that table, it does the SPF, and then it returns the routes for an optimized way. It really was just kind of a way for me to familiarize with the process that's running. One thing that's important, I guess, you may wonder, like, do I have to create sort of this ORR RIB for every client on my network? That sounds like kind of a scalability nightmare. I know, like, the network that I kind of previously was help running, in an ORR scenario, you might have had, 400 to 500 clients. It could extend out to, thousands of clients. So there's a good optimization method that all the vendors support, which is grouping nodes based on seed IP addresses. So now you're not using that direct client as the root for your SPF calculations. You're using that seed IP that's in the same region as the client. And the reason you do that is, in a lot of typical networks where I have, maybe a pair of aggregation routers that sit in front of lots of other routers, for the prefixes that are being, selected from a remote peer, the IGP cost behind those sort of ABR nodes and aggregate, they're not really important. As long as those nodes are sort of the forwarding path for all traffic to those exit points, we really don't care. So we can group all of those nodes behind those seed IPs. So, like, for instance, like I said, the network I was working on, we typically had 17 regions, and I could have used, I guess, if I had a primary and a secondary, 34 seed IPs. So I'm now creating potentially like 17 or even 34 RIB groups and not hundreds of them per client. So it's a very easy way to sort of optimize the scale of the optimal route reflectors. This kind of gives a list of the current known vendor implementations, and if anybody else has other ones they know of, or even open source ones, let me know. All the major I'll say major vendors, hardware vendors have all implemented this. Cisco's had it for quite some time, and the second bullet point is how they acquire IGP topology information. All of them support using regular adjacencies or GRE tunnels to ingest that LSDB topology information. Juniper was the only one that I found did not yet support BGP-LS to ingest that information. Nokia just recently implemented this on their boxes as well and support all of the different topology acquisition. This is just kind of a quick snapshot of how you configure this on a box. It's really simple. There's not a whole lot to it on any platform. I would say Juniper's a little different. I think if people are familiar with Juniper, most things are configured under a peer group explicitly. This is no different. You simply enable it under a peer group. Cisco and Nokia, you create the ORR group outside of the peer group configuration, and then you reference that when you create the peer. So it's all fairly good. I would say it's from an operational details, it's still fairly sparse. It was kind of one complaint I have with the Cisco implementation is you don't get a lot of data, operational data, unless you kind of turn on debug information. And even though I was a Cisco employee, I was fairly impressed with what Nokia had implemented for their operational commands. Was kind of very full featured. Here's some sort of limitations with optimal route reflection. One thing is there's no concept of any dynamic peer grouping. And there's actually some talk about this in the original ORR draft that's been dropped over time. Like that draft has been simplified greatly over time about how to group nodes based on specific topology information. Like I said, if you're in a typical network scenario where I've got aggregation nodes that are AVRs and all the nodes sit behind those, you can sort of make the assumption that if I have a client behind say a configured seed IP, that I should automatically add it to that group. But today, none of the kind of nodes do that. I have to do an explicit configuration that says this client belongs to this group. And I have to configure the seed IPs as well. I gave the caveat here, if you want a specific ORR group for every client, it's a lot of groups. I'm not sure there's too many networks where you would want to do that. There's also potential scale limitations. You are running an SPF, on behalf of all the clients that are defined, or at least all the groups that are defined on the router. I've seen some pretty large IGPs, and the example here is if I've got 10,000 nodes in a flat IGP, and I have to run that every time there's a topology update, and I've got say 20 ORR groups defined. That's a lot of work, even for kind of off-box compute. That's still a lot of computation that has to happen all the time. Now you can scale, virtual route reflectors pretty easily horizontally, so it may or may not be a big issue. But there's sort of this matrix of different values as far as IGP scale, number of groups, number of clients, and there's definitely limitations there. Potential synchronization issues. You're not sort of right next to the IGP you're serving. BGP-LS is pretty fast, so I consider this kind of a minor issue. Another issue that kind of I ran into just in my testing and the original, if you want some good information on hierarchical IGP issues, the original ORR draft actually has a fairly large section that covers this. SPF kind of across boundaries doesn't work very well. So if I've got sort of a multi-level ISIS domain or OSPF areas, you can run into areas with like say ABR summarization where I kind of lose the next hop addresses. But even in the case where I'm leaking next hops, there are some limitations in spanning sort of multiple areas and multiple domains. And the optimal route reflector actually being able to calculate that path across domains. Like I said, I've definitely ran into some issues with that with different implementations. I don't know that it's in sort of the typical kind of rewrite next hop at the ABR thing today, and if the ABR is my seed node, that's not too much of an issue. But I think as we go to sort of more end-to-end path engineering, I think it becomes more of an issue then. So here's kind of like, my recommendations, if somebody, not that anybody has deployed ORR yet, but if you are looking to deploy ORR, here's some sort of guidelines and recommendations. I definitely would recommend doing virtual route reflectors and sort of not deploying ORR on your kind of hardware router. I guess we're putting, faster processors and more memory into kind of hardware routers all the time these days. But due to, power and temperature constraints and things like that, they still pale in comparison to even sort of the lowest class kind of off commodity server. So I definitely would look at putting this on sort of a commodity server compute cluster type hardware because it's easily scalable. It's easy to spin up more of them if you need them. Topology acquisition. I kind of covered this a little bit in the past, but I completely recommend using BGP-LS if you have it available. BGP-LS is not supported on sort of all routers, so a potential option is to do an IGP adjacency to some sort of other virtual router that then feeds the information to your VRRs. I would say, kind of the last resort is to, use something like GRE tunnels to get that topology or use direct adjacencies. Client migration, it's just another route reflector. There's not really anything special about that. You've got to spin them up and rehome clients as you need to. Like I said, here's kind of my simple example of the flat IGP. The flat IGP example is pretty simple. Like I said, hierarchical adds some complexity depending on how far you want to stretch BGP next hops across your network. Like I said, you could use IGP adjacencies. But, and as I mentioned, add path is, these aren't mutually exclusive options. So you can definitely add path with optimal route reflection. And kind of one benefit is that optimal route reflection, like I said, the example where I may be getting, 6 paths from different peers across my network, it will choose the best n number of paths based on that IGP cost. So it truly is a way that I can, add resilience and things through add path, but still get sort of the benefit of optimal route reflection. This is sort of a slide that covers, how do I, scale clusters. Let's say I have, hundreds of potential clients that are connecting to the sort of the centralized route reflection infrastructure. And the example here is I may have, many IXP peering routers. They're getting the same routes, say from, the same transit connection in multiple peering centers. Kind of the easiest thing to do is just have, unique sessions from those to every, VRR that's running ORR. Even traditional, hardware routers today scale much higher as far as sessions do than they used to. If I've got, potentially 50 ORRs, it's not a stretch to run that many sessions from, peering routers today. There's other options. I could use intermediate route servers. I could use add path between those boxes. But like I said, using just, normal sessions between the IXP routers and the VRRs is probably the best solution and the easiest to follow. Like I said, it's easy to spin up additional VRRs. The VRRs also scale fairly high. There's obviously the matrix of different values that you have to follow as far as scaling guidelines with optimal route reflection. But, in most of my testing, VRR today can handle, hundreds of clients without much issue. And I guess, the future of ORR, optimal is kind of a funny name because, optimal is kind of the eye of the beholder and what really is optimal. I think the basic things are enhance ORR to, increase scale, performance, things like that. One thing that I would like to see is sort of this dynamic grouping of common ORR peers via like a topology inspection. Like I said, it's something that's mentioned in the older drafts and I think is worth the benefit as to having to do sort of that manual assignment of peers to groups. And then the second half of this is kind of, the second part of the existing draft, which is really adding more things to that best path selection process. And there's, drafts today that cover like almost a user selectable best path selection. It's really about being able to kind of insert your own logic into that best path selection process. And I think that's the way things are going. The SPF method of doing this is really just kind of a starting point to a more user definable, BGP or a more programmable best path selection process. So I think you'll see more and more of that in the future and, potentially adding more functionality to this. The nice thing about something like a virtual route reflector is you sort of get enhanced, velocity with features. It's easy to spin up new ones that have new features. I'm not touching like a, a hardware router deep into my network. So it's easy to kind of add these enhancements over time. And that's it, if anybody has any questions. Okay.
I only see V4 being mentioned in your slides. Do you support V6 yet?
I would say the V6 support for optimal route reflection is fairly weak at this point. I think people had wanted to get the V4 stuff working and stable first. And like I said, it's fairly new technology. It's been recently implemented. I think V6 support is coming. I'm not going to speak to Nokia and Juniper. I honestly don't know. But from the Cisco part, I think it's coming in the future.
Okay.
So
Thank
I
you.
got one quick question for you. So Andrew Gray with Cox.
Surprising.
Yes, very. Quick question for you. So kind of looking at how this could potentially break, you're exposing yourself a little bit to IGP noise. So say, for example, you have a link flap in a core. What are the gains, the losses compared to standard BGP route reflection you've seen? Are there any good little tips or tricks on how to mitigate that somewhat?
I would say there's not a lot. It's sort of one of the things you have to take with it is if you have a ton of IGP instability in your network, it is going to contribute to, it might necessarily contribute to, BGP flaps and things like that, or withdraws and those types of things. But it's going to create load on that device, or that device is doing the optimal route reflection. If you take a link down or a node goes down, it's going to rerun SPF every time. Like, so that's part of the scaling guidelines. You really have to take that into account. If I have a ton of network instability on my core, I probably have other problems, but it is going to affect that process.
All right, thank you.
Hi, Tom Carter, Charter. I had a question about, so on one of your slides you had mentioned using virtual route reflection as like a VNF inside a data center.
Yep.
Do you see problems when you may be hosting routes to that data center inside that route reflection, inside the VNF, inside the data center?
Yeah, potentially. I mean, there's sort of this, you're relying on the connectivity to that element in your network, and you're also serving, a critical part of your network out of there.
Yes.
And that's where, I would always deploy things in a redundant fashion. And this is fairly easy to deploy. Lots of people use, multiple route reflectors for redundancy today, and this is no different. I think in this slide I said, definitely don't put all your eggs in one basket.
Yes.
You definitely want to add that redundancy. It's similar with other things like path control, PCE is the same thing. It's like, yes, I'm, controlling this critical element in a data center that's connected via the same network. You always have to have redundancy there for that.
Yes, thank you.
Thank you. Thank you so much. And thank you, our audience, for your participation.